Hello everyone, Dr. Data Science here to teach you data science methods and tools today, tomorrow, and beyond. One of the most common questions that I receive is how to decide if a data science degree is worth it. In this video, I'm going to share with you 5 tips to help you decide whether you should get a degree in data science, including pros and cons, and how to land a job. If you find this video helpful, please don't forget to like and subscribe. Also, if you have any questions, please leave your comments. First, we should ask this question that what is data science? Data science is an interdisciplinary field to extract knowledge and insights from different types of data. Data science is becoming critical for different organizations and companies to allow for data-driven decision making. A well-known example is the Netflix recommendations system that uses different types of information. For example, your ratings on movies that you have already watched, the time of day that you are watching movies, and the devices that you are using. And Netflix uses all these different types of information to make predictions of what you're most likely to watch in the future. Another example is collecting data using wearable devices such as Apple Watch and sensors to motivate individuals adopt healthier habits, such as tracking how much water you drink every day, and also to alert users to potentially critical health issues. Moreover, data science helps for efficient food growth and cutting down on food waste to enhance farming techniques. Therefore, there is no doubt that data science is helping the future, and also it's not surprising that data scientist has been named as one of the best jobs in America. According to Glassdoor, an average US-based salary of a data scientist is about $113,000 in 2020. Now I want to share with you 5 tips to see if you should get a degree in data science. Tip number 1 is that you should always look at this data science lifecycle. Each data science project has 4 main stages: understanding the problem, data acquisition, modeling, deployment, and customer acceptance. The first part of each data science project is that you should have a well-defined problem, and you should also identify goals, steps, and deliverables. After this step, you should collect data. So we are in the data acquisition step. And this step also involves data wrangling, exploration, cleaning, and data annotation. And honestly, this is the part that has been overlooked a lot, but in my opinion is one of the most important parts of this data science lifecycle. And it can be also very time consuming and expensive. For example, let's say you want to have a startup company for developing computer vision techniques for classifying medical images, such as X-ray images. So in this case, after collecting data, you need to have some domain experts, such as some physicians, to be able to tell you the difference between X-ray images. So this is the part can take a long time, and obviously you need to have domain experts that can do data annotation. Next, we have the modeling part. In this case, if you use machine learning and deep learning and other techniques to extract information from process data that we have from the previous stage. And most of the topics that you see on YouTube and a lot of programs that are online based on this modeling part. And finally, the last step is to deploy your model. And here is the part that we do: scoring, performance, data visualization, and decision making, which all of these steps allow you to understand whether your developed model meets the requirements that you had when you define the problem in the first stage. And obviously we have interactions between all these 4 stages, because sometimes you may have to go back to data acquisition part and collect more data set. or sometimes you have to change the problem that you had at the beginning to make sure that the deliverables are modified according to what it is achievable in your application. So if you're interested in data science, you should have this picture in your mind and know exactly what area you want to specialize in. I know that many of people they like the modeling part, but there are also a lot of opportunities for people who are interested in more data acquisition and data exploration part, or also people that they may want to be involved in deployment and data visualization part. The second tip is related to data science curriculum. So when you're looking at different programs from different universities or different online programs, you have to be careful about what types of courses they offer. One of the most important things is that they should have mathematical foundations, meaning that courses such as probability, statistics, calculus, and linear algebra. In order to understand more advanced courses such as machine learning, artificial intelligence, and deep learning, you're going to work with a lot of vectors and matrices and probability distributions. So therefore, having mathematical foundations is necessary for succeeding in courses such as machine learning and artificial intelligence. In addition to these courses, you also have to take other courses in database, computer networks, and cloud computing. Because obviously, when you're working for a big tech company, you definitely don't have all the data that you need on your own computer or PC. So therefore, it is important to be comfortable with working, especially at this time, with cloud computing services. In terms of programming skills, Python is definitely a must-have, and you should be comfortable working with important libraries such as NumPy, scikit-learn, TensorFlow, and PyTorch. Scikit-learn has a lot of traditional machine learning algorithms. TensorFlow and PyTorch, they are very useful for implementing deep learning or neural networks. And in my opinion, in addition to Python, you need to have at least one more language that you're comfortable with. This can be JavaScript, R, or Julia. But overall, my recommendation is that you need to be really comfortable working with two programming languages. And the other important part here is that keep your programming skills up to date. To give you an example, TensorFlow 2.0 was released in September of 2019. This means that if you took TensorFlow 2 years ago, then you have to look at the new version and make sure that you know all the new features of TensorFlow. The third tip is to look at data science job descriptions that you find on LinkedIn and other websites. So you can go to LinkedIn and search for your favorite job at Google or Facebook and see exactly what they're looking for so you know how to invest your time. Here is another recommendation that I have. You can always use your data science skills with other skills that you have outside data science. So this means that, for example, if you have taken courses in biology before, you can see how you can use data science with biomedical data sets so that you can find jobs in, for example, pharmaceutical companies. Similarly, you can use your knowledge of electrical engineering to use in data acquisition part for wearable devices such as like Apple Watch because you need to use a lot of signal processing. Another example is the intersection of data science and mechanical engineering for a smart manufacturing, which means that we use a lot of data to identify the best way to manufacture certain items. And there are so many other examples. You can find different jobs at the intersection of data science and environmental sciences, physics, chemical engineering, and so on. So this is something to keep in mind because it will make you very competitive when you're trying to find jobs that require other skills. When employers look at candidates to hire, besides data skills that you have, they look at people who have the ability to communicate, collaborate with others, and take initiative. Therefore, it is critical to build your data science portfolio. This means that you should have a few projects up on GitHub or your blog. These projects should be based on interesting data sets. I definitely recommend you to look for data sets that are interesting. For example, data sets such as MNIST, which contains handwritten digit images that have been used a lot of times and they are not really standing out. So therefore, it is very important to find really interesting data sets, and each project should be well documented. And I definitely recommend you to use data cleaning strategies and lots of data visualization. So you have to plot very easy to read figures so that when someone looks at your GitHub page for less than a minute can understand what you have done and what kind of abilities you have to communicate with others. Another way to build your portfolio is to participate in data science competitions such as Kaggle, and this site Kaggle also has a lot of data sets that you can use for your GitHub page. Lastly, you should apply for data science internships because data science internships are really nice ways to show that you have worked with real data science projects in your resume. And the other nice thing about internships is that they have lower requirements than full-time jobs. The last tip, which is very critical, is to subscribe to Dr. Data Science channel. In this channel, you will see a lot of videos at the intersection of modeling and data acquisition. In the modeling part, we talk about machine learning algorithms, foundational aspects, and how to implement them. And then we see a lot of videos about how to find the right trade-off between quality of data and the performance of machine learning algorithms. And this is very important because if you don't have high quality data, then we cannot expect to extract useful information. Thank you for watching, and don't forget to subscribe to Dr. Data Science channel.